Now, before we get started, are there any questions over any of the assignments so far?
Yes. Number
3.42, number 4. So it's asking to find the conjugate, and the conjugate would be 7 plus 8i. And it also asks us to find their product. So to find their product, we take 7 minus 8i multiplied by 7 plus 8i. Now the graphing calculator, we could type it in exactly as it's written here, hit enter, and it will do it for us. And it'll tell us that this is 113. I know this because I've graded a few of these already, so. But if we did this by hand, we would just distribute. 7 times 7 is 49. 7 times 8i is going to be plus 56i. Negative 8i times 7 is negative 56i. And negative 8i times 8i is negative 64i squared. We'll still have the 49, but our positive and negative 56i combine together to be 0 minus 64. I squared is negative 1. I is the square root of negative 1. I squared is negative 1. Which negative 64 times negative 1 is positive 64. And if we add those together, we get 113. So the full answer for this problem is 7 plus 8i and 113. So we need the conjugate and what the product would be of the each conjugate multiplied together. So 1 through 5 on that page does have 2 answers. We have the conjugate and their product. I think you did. Your grade shows that you did get them. So you might have gotten it put down and didn't remember it, because you probably put the product, but if you wrote it out, if you actually wrote this out, I went on and took it. I think so, or I missed it, one of the two. You got a 10 out of 10. Yeah, as long as the 2 answers are there, I take them. Questions on the homework? We ready to start? 352 1 3 6 1. Completing the square. So before we start completing the square, we're going to go on and write the steps out for completing the square. Now the first step in completing the square, and you can write this, well, we don't need that, we can put it under here, is a equal to 1. If not, make it so. Is a equal to 1? If not, make it so. Bless you. Step 2, get the variables by themselves and leave 2 spaces. And when we say two spaces, we're really saying that you're going to need to leave a space on either side. Step 3. Find the value of c, which is equal to b over 2 squared, and plug in. And the last step, factor and solve. Now the fourth step that I have in the slides the other day was, steps 2 and 4 were a little bit more wordy than this, but this is the essence of them. Because I know step 4 was to factor the perfect square trinomial and then solve. And step 2 was to get the terms with a variable on one side and everything else on the other. In parentheses, get the constant terms, the terms without a variable, away from the variables. Now these are the 4 main steps for this here. These are the 4 main steps that we use to do completing the square. Now we've already solved this one here. We did this yesterday. Solve x squared minus 16x plus 64 equals 100. Now we're going to apply our completing the square method to it. Now this is already, as we saw yesterday, x squared minus 16x plus 64 is a perfect square trinomial to begin with. We're going to act like we don't see that and going to treat it like it normally would. And the first main step is a equal to 1. And our a is always in front of the x squared. Is the number in front of x squared 1? Yes. So here is a equal to 1. Yes. So we're good. We can move on. Because if not, we need to make it be 1. So we don't have to do anything there. So we still have x squared minus 16x plus 64 is equal to 100. Step 2. Get the variables by themselves and leave 2 spaces. We're wanting to get the constant term, the term without a variable, on the other side. So for here, we would indeed subtract 64 from both sides and then leave 2 spaces. And the reason we're leaving 2 spaces is, again, we're trying to make that perfect square trinomial. We're going to need to put that value of c back in. So we're leaving a spot on both sides to put it back in, because if we add something to one side, we have to add it to the other. Any questions on steps 1 and 2? Step number 3. C is equal to b over 2 squared. So b is the term in front of x, and our term in front of x in this case is negative 16. So to find our c value, we're going to have negative 16 over 2. When we plug in the value of b, we take the sign and the number. Variable is never a part of the value of b, because if you see in the general form still, it's b times x. b is just the number. Now we can do this here. Negative 16 divided by 2 is negative 8. And negative 8 squared is 64. And as you can see here, we kind of knew this at the beginning, and it kind of re-solidifies that it was a perfect square trinomial to begin with. But that also means, even if it was one to begin with, we do the steps, we'll still get there. It just kind of everything we did to this point just undid itself. So, and it also does help us with factoring. A different color, but that's fine. Because if I factor x squared minus 16x plus 64, since it is a perfect square trinomial, we'll have our parentheses squared. We will have our x. But finding c does tell me what the value that's going to go in there. Yes, it would be negative 8. is x squared minus 16x plus 64 does factor to x minus 8 squared. So it kind of helps us also get that there. 36 plus 64 is 100. No, not always, but it does give us the ability to take the square root of our quadratic. That's the goal of this. That's the goal of completing the square, is that we turn whatever's on this side into a perfect square trinomial, something we can rewrite as a set of parentheses squared. So that once because we've actually started moving into step 4, factor and solve, that now we can solve by taking the square root of both sides. And on the left-hand side, the square root and square would cancel, leaving us with x minus 8 equal to plus or minus. When we take the square root of both sides, we need to remember the plus or minus. And the square root of 100 is 10. Now we're not quite finished with solving, because x is not by itself. We would need to add 8 to both sides, telling us x is equal to 8 plus or minus. Questions on this here? I would always stick with whatever we add, putting it first, so that we have the plus or minus 10. Because it's not technically wrong to have plus or minus 10 plus 8, but we really want that 8 in front. We want that 8 front. Because the plus or minus is telling us two things. One, that this is saying that we have 8 plus 10. And secondly, that we also have 8 minus 10. Because we're saying 10 is both positive and negative. We have two cases. And the plus or minus lets us be able to say both statements at the same time. Now, the only time that we have to split it up is if we could actually simplify. Can we do, or simplify 8 plus 10? Yeah, 8 plus 10 is 18. And 8 minus 10 is negative 2. So because we could add or subtract them, we need to add and subtract them. Now, if it had been 10i, or 10 times the square root of 2, we leave it because 8 and 10i, or 8 and 10 square root of 2, are not like terms. We cannot combine them. Then we leave it as the plus or minus. Do we see the difference, or kind of understand the difference between those two? I about said, can we see it, but it's not written there. So, questions on this here? All right. I want to skip that one because that second one, I don't know if it's in your note sheets. I think it is. Yes. X squared minus 6x plus 9 is a perfect square trinomial. I want us to get to one that isn't. X squared minus 4x plus 8 is not a perfect square trinomial. And x squared, was it minus 4x? 4x plus 8 graph. I'm showing you this here because it does not cross the x-axis. So by graphing, it has no real solutions. Technically it is factorable, but to be able to factor it, we really need to know what the solutions are to be able to get back there. So the only method that works for this is completing the square. That's the only one that works. So we're going to go through the process for this here. Step number 1, is a equal to 1? Yes, number of root of x squared is 1, so we're good there. We can move to step 2. Get the variables by themselves. So we would indeed subtract 8 from both sides. We're getting the x squared and negative 4x by itself. And leave 2 spaces. Because we're leaving a space to put that c, that value that will make it a perfect square trinomial, that we can rewrite it as a set of parentheses squared. And that's why this is so nice, because it does work every time. No matter what the solutions are, no matter what the setup, this method will always work. Now, c is equal to b over 2 squared. The value would be 4, but it would be negative 4. We take that sign with it, so it would be negative 4 over 2. Now, again, we could plug this in parentheses negative 4 over 2, close parentheses squared. But again, I would divide first, if you can. If, like this one here, negative 4 over 2 is divisible by 2, divide it before we square it. Because the number inside the parentheses before we square it is going to be the same number that goes inside the parentheses with x. It gives us that. Because if we just straight plug negative 4 over 2 squared into the calculator, it would tell us that it is 4, but we don't get that in between. That kind of, this is the other part of the factors. Now we will plug it in both spots. We'll add it to the left and right side. We do. But we put it in when we factor. Because we need the actual value of c to add to both sides. That way we know that the perfect squared trinomial is x squared minus 4x plus 4. Since we added the 4 to make it a perfect squared trinomial, we know we also have to add to the other side to make it still balanced. But when we factor x squared minus 4x plus 4, that negative 2 is what goes inside the parentheses. Because x minus 2 squared is our x squared minus 4x plus 4. We kind of see the difference. So that's where the negative 2 comes in. On the other side, negative 8 plus 4 is negative 4. Now, we are in step 4. We've been in step 4 for a minute because we just finished factoring. Now we need to solve. So we can take the square root of both sides. So left-hand side, the square root and square will cancel, leaving us with x minus 2 is equal to plus or minus. Whenever we take the square to both sides, we have to add the plus or minus. Now we're taking the square root of negative 4. The negative will come out as I. Square root of 4 is 2. So it simplifies to 2i. Square root of negative 4 is 2i. Is x by itself. So the last thing we need to do is add 2 to both sides. The negative 2 plus 2 will simplify, leaving us with x is equal to 2 plus or minus 2i. Questions on any of this here before we... Now, are 2 and 2i like terms? No. The I makes it so they're not like terms, so that there's final answer, because there is no way to combine them. The only thing we could say is that x is equal to 2 plus 2i, and x is equal to 2 minus 2i. It didn't change anything. It didn't make it any simpler. That is the final answer. Questions on any of this here? We're going to look at another one. So this one here is not factorable. I have a feeling it's also not graphable, because there are no factors of 5 that will get us to 8. It just doesn't work. So we can go through our process of completing the square. First step is a equal to 1. Yes. So we can move on to step 2. Get the variables by itself. So we will add 5 to both sides, telling us that x squared plus 8x plus blank is equal to 5 plus blank. Luckily for us here, we will not get imaginary solutions. We won't have I. Well, we will have radicals. Yes, now we need to find the value of c. Well, c, in our case, is equal to b over 2 squared. b, in this case, is indeed positive 8. 8 divided by 2 is 4, and 4 squared is 16. Now our 5 plus 16 will be 21. And as we start step 4 with factoring, our x squared plus 8x plus 16, the number that we put in there will be 4, and it will be plus. Questions on how we got to this point here? Now the next step in solving is to square root both sides. Yes. Telling us that x plus 4 is equal to plus or minus. Well, it's not negative, so we don't have I. Yeah, square root of 21 is square root of 21. So it just says square root of 21. And last but not least, to get x by itself, to finish solving this, we need to subtract 4 from both sides, telling us that x is equal to negative 4 plus or minus the square root of 21. Negative 4 and the square root of 21 are not like terms, so we're done. Because if we get a number and another number with I or a square root or I and a square root, we can't combine them. There's no way to simplify that further. That is the final answer. That's also part of the reason why we couldn't factor the thing. Questions on this here? Questions on any of this so far? How do we feel about these here? I mean, for the most part, it's not a whole lot to it, because if we know how to find C, everything flows from there. Let's look at this one here. Is A equal to 1? If not, make it so. We have to divide everything by 3. And this problem is nice. See, as 3x squared divided by 3 is x squared, just like what we wanted. 12x divided by 3 is 4x. 15 divided by 3 is, and 0 divided by 3 is 0. It came out to this here. Now, it looks like we could factor this, but we can't. It would only be factorable if the 4x was negative. No, sorry, if the 5 was negative. Because with the 5 being positive, the factors have to be the same sign. So it's not going to work out. We'd have to subtract. And again, if that's not something you automatically see, you're in the normal group. I've done these too long. Literally, I've done this one too long. So I also know how this works out. But no matter how it's set up or how it starts, this method will always work. So is A equal to 1? No. If not, make it so. We did. Step 2, get the variables by themselves. So we would almost subtract 5. Because if it had been minus 5, then indeed we would add. You're good? So we'd have x squared plus 4x plus blank is equal to negative 5 plus blank. So we moved the constant term by itself and left 2 spaces. C is equal to b over 2 squared. Our value b is indeed 4. 4 over 2 squared. Well, 4 divided by 2 is 2. And 2 squared is 4. Are we comfortable with how fast I just went through that? So our value of c to make this a perfect square trinomial is indeed 4. Set of parentheses squared, x plus 2. Because the number inside the parentheses before we squared it was positive 2, giving us x plus 2 squared equals negative 1. Not the last step, but we're getting there. Towards solving, we need to square root both sides. Here, the square root and square would cancel, leaving us with x plus 2 is equal to plus or minus 1i, just I, because I, by definition, is square root of negative 1. Yes. And the last step would be subtracting 2 from both sides. Minus x is equal to negative 2 plus or minus I. The negative 2 and I are not like terms, so we can't combine them by adding or subtracting. So it's just this here. Question. Number 10. Any questions on this here? It is different. So we can look at number 10, because 9 and 10 are both the same type thing. Now the nice thing with 10 is actually nicer than 9, because first step, if we do have time to do 9 too, we will. So 10 is a equal to 1. So we would divide everything by 4. So we have x squared plus 8x equals negative 68 divided by 17. Now I left a spot intentionally, but that's fine if you didn't, because we got a equal to 1, yes?
Yes.
What's step number 2?
Get the variable by itself. At least two things.
Wait, are the variables by themselves?
Yes. Huh.
That's the nice thing about 10. The constant term, the number we would have needed to get to the other side, is already by itself. If we had variables over where the negative 17 is, we would add them back over. We would just rearrange it so the x squared and x are on one side. Everything that does not have a variable is on the other. So if, I'm going to erase this here. You do not have to erase it if you already have the spaces. Because if you wrote it as this here, all I would need to do is just rewrite it and put the spaces in. Already set up the way we needed. That's why this one's a little bit nicer than 9, because we didn't have to subtract the 17 over. It already had it for us. And we can move on to step 3. C is equal to b over 2 squared. So b is our positive 8. So our b over 2, 8 over 2 is 4. And when we square it, we get 16. And it does tell us that x squared plus 8x plus 16 is our perfect square trinomial. Equals negative 17 plus 16. So when we factor x squared plus 8x plus 16, x plus 4 is equal to You're good. I have a feeling you know what you were doing. It just wasn't coming out right. Last step, well, not last step. Square root, both sides. They would indeed cancel, telling us that x plus 4 is equal to plus or minus I. Minus 4. There is another way that works every time. And that's the last thing we're going to do with this chapter. A little bit. It is purely plugging numbers in. I wouldn't necessarily plug it all in, but you can for the most part. Questions on any of this here? So we feel comfortable with this here, yes? Right. It's just a little time consuming and just taking it one step at a time, yes? So just, yes. Number 9. Is A equal to 1? We divide by x squared plus 6x plus 1 is equal to 0. Because again, the first step in completing the square is A equal to 1. And it's positive. It needs to be positive 1, not negative 1. So we divide by negative 3. If it had just been negative x squared, we divide by negative 1. Yes, thank you. I think that answered everybody's confused face. So we get this here. Now, we move to step 2, get the variables by themselves, which tells us that we have x squared plus 6x plus blank is equal to negative 2 plus blank. Because once we got A equal to 1, we need to get the variables by themselves and leave 2 spaces. Brings us to step 3, the value of C. B over 2 squared. Value of B is positive 6. So 6 divided by 2 is, and 3 squared is 9. So we'd have 9 and 9. So x, the number we had before we squared it was indeed positive 3, so it'd be x plus 3 squared equals, because negative 2 plus 9 would be positive 7. Now we can solve by square root. So we have x plus 3 is equal to plus or minus the square root of 7. 7's prime. That's as simplified as it gets. And now the last step, we need to subtract 3 from both sides. 3 plus or minus square root of 7.
How did you decide that this is what you wanted to do?
I haven't mastered it, but I do enjoy it. And I do like teaching, so. Questions on any of this here? Questions on anything we've done so far? Well, before we completely wrap up, because we do have a few minutes, I do have one more, because as y'all have noted already, number 20 is not on there. It's not on the note sheet, so I want you to kind of watch this one. This is quote unquote turning the difficulty level up a little bit. But if we look at number 20, we need to divide by 2. And yes. Now 2x squared divided by 2 is x squared. That is exactly what we want it to be. But with any of these here, if we end up getting fractionals or fractions that doesn't divide evenly, we reduce the fraction as far as possible, but leave it as a fraction. So we get this here. So it tells us that we have x squared minus 5x plus 67 halves. Step 1's done. Step 2. Subtract 67 halves from both sides. These will cancel, telling us that we have x squared 5 halves x plus blank equals negative 67 halves plus blank. Have the steps really changed? No, the numbers look not as nice, but everything's still following the same pattern, yes? C equals b over 2 squared. Negative 5 halves over 2 calculator, because it does reduce down to negative 5 fourths. So we won't have a fraction in a fraction. We will just have a single fraction of negative 5 fourths. And if we square this, we do get 25 over . Now it seems, or would appear, trying to factor x squared minus 5 halves x plus 25 sixteenths would be a little challenge to factor. We would have x, because again, it still holds true. Whatever that number is before we square it is what goes in here with its sign. So x minus 5 fourths squared is x squared minus 5 halves x plus 25 over 16. We would add those two together. And again, I would just go straight to the calculator. Let it negative 511 over 16. Again, at this point, we would square root both sides. Here, the square root and the square would cancel, leaving us with x minus 4 is equal to plus or minus. Whenever we have a fractional number we're taking the square root of, the yellow calculator will do it for us, but I do have to take the negative out as I. The negative has to come out as I. Second square root of 511 over second square root 25, yes? 16, yes. Well, it's square root 511 over 4. It is indeed. Or it doesn't have any perfect square factors. No. 711 is not prime. 7 plus 1 is 8 plus 1 is 9. 711 is actually divisible by 3. But before y'all leave, we do have this here. That last problem is not on the worksheet, not on your homework. I think I grabbed that from a college website. But I wanted to show you that to show you, even when the numbers aren't great, aren't nice, the process still holds true, the steps still hold true. It's not insanely more difficult than what we're doing. Just the numbers work out better. If you do have questions, please ask. I will help you with those. Thank you. I will take your homework assignments. And on the plus side, there is only one more assignment after this. Yes.